So in this video, we're going to look at section point one, which is on transformations of graphs. So different ways we can move graphs. So our objectives are, we're going to look at the end of this, a function that looks like this, where a, b, h, and k are all numbers. And we're going to be able to explain the impact each of those numbers have on the graph, how it shifts the graph or stretches or compresses it. So we're gonna use that to be able to graph transformations and then also be able to explain the different types of transformations. So the first transformation is vertical shifts. Okay, and we're gonna do a little bit of a discovery. So I highly recommend pausing this video, graphing x squared, and then graphing these two functions and looking at them and thinking about, okay, what happened to f of x? How did it change before I go through it? Because if you like do it yourself and kind of understand what's going on, it might help you in the long run understand this topic more. Okay, so the first thing we're going to do is graph the function f of x equals x squared. And at this point, I'm hoping you mostly know what x squared looks like, but if you don't, again, you can always make like your XY table. But this is one I highly recommend that you make sure you know what it looks like. Okay, so you can always plug in your points and you get this, but it would be really beneficial if you know that on x squared, you always have the point 0, 0, 1, 1, negative 1, 1, and 2, 4, and negative 2, 4. And then it makes this U. So this is our graph of y equals f of x, which is x squared. So we're going to look at two other functions, g of x, which is x squared plus 2, and h of x, which is x squared minus 4. Okay, so for g of x, we're going to start that. We're going to plug each of these into this function and then graph it. So we have negative 2 squared plus 2. I'm plugging this x value into my g of x. Negative 2 squared is 4. So 4 plus 2 is 6. Negative 1 squared plus 2, and I'm plugging into this function, gives me 1 plus 2, which is 3. 0 squared plus 2 gives me 2. 1 squared plus 2 gives me 3. And then 2 squared plus 2. 2 squared is 4, and 4 plus 2 is 6. And then I'm going to graph this function in blue. So I have the points negative 2, 6, negative 1, 3, 0, 2, 1, 3, and 2, 6. I'm just gonna fix my graph of x squared because it does not go through 2, 6. It goes through 2, 4, and then it comes out here more. Okay, so if we look at this, what happened was that the graph of x squared was just shifted up 2 values. Okay, so we look at when it was negative 2 originally, it was at 4. And now it is at 6. And so it's 2 higher. And when it was at 1 initially at negative 1, now it's 2 higher at 3. And when it was at 0, we had a y value of 0, and now it's up 2. So when we have g of x equals x squared plus 2, what happens was the graph of x squared, or f of x, is shifted 2 units up, okay, where we added 2 to every y value. So that's what happens when we added 2. What happens if we do h of x, where we do x squared minus 4? So again, we're gonna plug each of these values into this function. And again, you could pause and then check your answer. But negative 2 squared is 4, 4 minus 4 is 0. Negative 1 squared is 1. 1 minus 4 is negative 3. 0 squared minus 4 is negative 4. 1 squared minus 4 is negative 3. And 2 squared minus 4 is 4 minus 4, which is 0. Okay, so I'm going to plot this graph. So I'm going to plot the point negative 2, 0, negative 1, negative 3, 0, negative 4, 1, negative 3, and 2, 0. And so we get this red graph. So again, same shape, but now we're comparing it to the purple one. And compared to the purple one, the red graph is shifted down, each point is shifted down per unit. So this one is down 4 units, 1, 2, 3, 4. When it was at 1, this is shifted down 1, 2, 3, 4. This point here is shifted down 1, 2, 3, 4. So all of these y values are 4 units below the original. And so when I have h of x equals x squared minus 4, it shifts x squared down 4 units. So this is the first rule we're going to look at when we're adding or subtracting a number from a function. Right? And so it's called a vertical shift. So if we talk about k being some constant, where k is greater than 0, so it's positive, we're going to look at how each one is formed. So my function g of x, if we add k and we say it's on the outside of the function, then what we say is that this shifts f of x up k units. Okay, so we would just count up that many units for each one. Okay, or we add k to each y value of f of x if you have a table. If we have f of x minus k, the minus shifts all the y values down. So this shifts f of x down k units. Okay, or we can think about it as we subtract k from each y value. Okay, and the x value doesn't change. So these transformations are called vertical shifts. And again, we think of k as outside of the function. It was outside the x squared. My original function was x squared. I was adding it or subtracting it from that function. So this is our first rule that we have to know. Okay, vertical shifts. So we're going to also look at horizontal shifts. So for horizontal shifts, what we're going to look at is we say that we're adding or subtracting something inside the function. So see how the x plus 3, the plus 3 is inside the squared? That's called inside the function. Versus when we have like x squared plus 3, what we just looked at, this 3 is considered outside the function. So when I talk about inside and outside, that's what I mean. So we're going to look at graphing these two graphs and how they impact it. And maybe you could think about, okay, what do you think it does? So we're going to plug negative 2. So again, we should know this one. When it's negative 2 is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. Okay, so then I'm going to do this one. So I have negative 5 plus 3 squared. Okay, remember order of operations, parentheses before exponents. So negative 5 plus 3 is negative 2, and negative 2 squared is a positive 4. Negative 4 plus 3 squared is negative 1 squared, which is 1. Negative 3 plus 3 is 0, and 0 squared is 0. Negative 2 plus 3 is a positive 1. And then I'm going to square it and get 1. And negative 1 plus 3 is a +2, and then I'm gonna square it and get 4. Okay, and so again, I just plugged each of these values into this equation and I simplified it. So I'm gonna plot both of these points. I'm gonna plot my f of x graph in blue. So again, this is our normal one that hopefully at this point you're pretty familiar with. And it's 3, 9. So just so that I get it more accurate, I'm gonna plot that. So this is my f of x equals x squared. Then I'm gonna graph g of x. So I'm gonna plot these points to graph it. So I have -5, 4, -4, 1, -3, 0, -2, 1, and negative. Okay, so now I have them plotted correctly. So I have this parabola here. Okay, so notice it's the same as the blue, except it was shifted. But unlike we thought, okay, so or maybe you thought that I would shift it right 3 because it's +3, it didn't. It actually shifted it left 3. So g of x equals x plus 3 squared is f of x shifted 3 units left. Okay, so each point, when I started at 0, it went 1, 2, 3 to the left. This point here at -1, 1 went 1, 2, 3 left. That's what I mean by shifted left. Each point I could count 3 to the left from the blue, and that's where the purple ended. And that's called a horizontal shift. And it kind of doesn't seem right, but the reason why is here, when I square -2, I get 4. To make this inside -2, my x value has to be -5, because -5 plus 3 is -2. So to get the inside here to be the same as the original, I'm actually putting values in 3 to the left of each of these x values. And that's why we're actually shifting the opposite way. And so when I add 3 on the inside, I'm actually shifting left. And then we can do one if we just look at plus, kind of the same idea, or sorry, looking at minus x minus 2. So again, we have our x squared. I'm just going to fill that in quickly. Okay, and then I'm going to do x minus 2 squared. So I'm going to plug in 1. I have 1 minus 2 squared, which is -1 squared, which is 1. 2 minus 2 squared, which is 0 squared, which is 0. 3 minus 2 squared, which is 1 squared, which is 1. 4 minus 2 squared, which is 2 squared, which is 4. And then 5 minus 2 squared, which is 3 squared, which is 9. And then I'm going to plot again my two graphs. So I have my original of y equals f of x, which is x squared. And then in red, I'm going to plot my g of x, which is x minus 2. So it's 1, 1, 2, 0, 3, 1, 4, 4, and then 5, 9, just like one above. So if you wanted to do like -1 to get the complete picture, if you do -1 minus 2, not -1, if I want to do 0 just to see where that is, 0 minus 2 squared is -2 squared, which is 4. So we get our u again. And so I get this. So again, it's similar to the blue graph, but each point is shifted 2 to the right. So this point is now here, 2 to the right. This point is 1, 2 to the right. This point is 1, 2 to the right. Okay, and so again, it's opposite of what we think when it's inside. So g of x is f of x shifted 2 units right. And again, the reason is because when I like plug 2 in is when I get 4. To get 2 in here, I actually have to plug 4 in to get 2 in the middle. And that's why it's shifting the opposite of what we thought. So the rules for horizontal is if C is some number greater than 0, if we have f of x minus c, how it's going to shift is f is shifted c units right. Okay, so anytime it's minus, we move right. And then this one, f is shifted c units left. Okay, so plus is left, minus is right. Okay. And these are called horizontal shifts. So we're gonna count right or left when we're shifting it. So I have 2 other like practice examples, quick, just to like talk about what we're doing and how to apply it, and then we'll look at the reflections. So it says, explain how the function g of x equals f of x plus 5 minus 2 is transformed. Okay, so we're looking at 2 things. We have plus 5 and we have minus 2. We're going to talk about how does it change each graph. Okay. So the plus 5 is inside the parentheses, so it's inside f. Okay, and whenever it's inside, it shifts your x value. It shifts it horizontally. And remember, it's always opposite. So we would say g is shifted 5 units left because from this. Okay, so inside shifts left or right, and that one's left. The minus 2 is the outside of your f. So when it's outside the parentheses, it's outside of it. And that moves it up or down. That's vertical. And it follows what we think. If it's plus, it's up. If it's minus, it's down. So G is going to be shifted 5 units left and 2 units down. So if you have to explain the transformation, you're going to say, how is it shifted? Okay. And again, outside shifts the y values up and down. Inside shifts the x values left and right. The second thing is graph the function y equals x minus 1 plus 3 using transformation. So I'm going to draw our graph here because I don't have a grid. Okay, so first thing is you have to identify the parent function, and this function, parent function, would be the absolute value of x. Okay, so the parent function is just the function without like the plus or minus or any of the shifts. That's our parent function. And so we have to remember what that looks like. Again, you can always make a table if you forget. Really quick, but the absolute value of -2 is 2. The absolute value of -1 is 1. 0 is 0. 1, 1, 2, 2. And so remember, this makes like a V. So that is the absolute value. So we're going to now graph this based on knowing this, using our transformation. So we know from this, the -1 shifts each point right 1. And then we're going to go the +3, which is on the outside. Okay, so the -1's inside, so that's changing left to right. This +3 is outside the absolute value. It's outside the fraction, so that changes the y value. We're gonna go up 3. And so each point, that's how we're gonna shift it when we graph it. So at 0, 0, I'm gonna shift it right 1 and then up 3. My point 1, 1, I'm gonna shift it right 1. Okay, so I was here 1, 1. And I'm gonna go right 1, up 3. Okay, and it might be easier to do it on the same axis. So this one is shifting right 1, up 3. This one is doing right 1, up 3. This point is going right 1, up 3. Right 1, up 3. This point is right 1. And then we get our V again. And again, our V should be shifted right 1, up 3 from each point. And again, you could do it on the same graph or a different graph. I think it's actually easier on the same graph. But we keep the same shape. We just now have shifted it. Okay, and so that's what we're going to use transformations from, to easily graph other functions from our parent graph, and then to describe the shifts of left and right. So those are the vertical and horizontal shifts, the first one.